In this video, we're going to learn more about the light sensor on the JackBord Basic. This lets us measure the amount of light in lux. This is the third of 10 videos in this Level 1 series on sensors. For this video, you're going to need the JackBord Basic, a USB-C cable, a PC or a Chromebook, and either the Google Chrome web browser or the Microsoft Edge web browser. So to begin with, let's find out what is light. Light is made up of small packets of energy called photons. And our eyes have evolved to detect photons that strike them. So when photons enter our eyes through our front lenses, these register in our brain as images. We only see an object if photons of light strike the object first and are reflected back towards our eyes, or if the object, like a light bulb, emits light by itself. That's why when you turn on a torch at night time, you don't see a solid column of light. You only see light that is reflected off something else. The light sensor uses a special type of diode, which is shown in the red circle here, that is sensitive to light, and this is the detector. The electronics in the chip convert the light value from the diode into a value that the JackBord can understand, and we end up with a light reading in lux. Here we can see the block diagram of this particular light sensor, which is the one inside the JackBord Basic. And essentially there's the detection diode, so this is what actually measures the amount of light that's falling on the sensor. This little chip here converts the analog value, which is a voltage, into a digital value. And then this is the processing block that we were talking about before. So this takes this digital reading and it converts it into a usable value. And then finally, the output section is this part here. And this essentially takes the value from the logic or the processing section and turns it into a data stream that the JackBord Basic can then use. And if we refer back to our original parts of a sensor slide, you can see the different parts of the block diagram down here. And so again, the detector is the diode. The processor is this middle section here, and then finally the output is this side over here. So once again, all sensors have three basic parts: the detector, the processor, and the output. Ambient light levels are measured in lux, and basically this tells you the amount of light falling on an area of 1 square meter. And the JackBord Basic measures light in lux. So if we look at the table on the right hand side here, we essentially have a moon, and a moonless night is effectively 0. Then a full moon might be 0.1, right up to your average living room, which might be 50 to 200 lux, or office lighting 320 to 500. And then a cloudy overcast day is 1,000, right up to full sunlight, which is between 10,000 and 25,000. And so these are some common lux values that you'll find in daily life. Now there are a number of ways that you can get the readings from the light sensor on the JackBord, and the first one is by using the command line and typing in the GT command. And when you do this, you'll see the light readings on the right hand side. Okay, I'm here on the command page, and you can see in the bottom right hand corner there I've got the JackBord Basic set up. So if I just go GT, which is get the readings, the current light level is 214 lux. So I've got a light here, so if I turn the light on and then I run the GT command again, you can see it's gone up to 219 or 297 lux rather. So with the GT command you can get the current light level in lux from the JackBord Basic. Now a second way that you can get access to the light reading from the light sensor on the JackBord Basic is by using the s_light system variable. And the s underscore at the beginning tells you that this is a system variable. And it's used essentially like any other variable. For example, here we're printing out the value of the light reading, and you can see that right now it's 161 lux. So this is another way that you can access the value of the JackBord's light sensor via a built-in variable. So I'm back here on the command line and we'll see what this command was. So basically it was JP, which is a way of printing. Let me go light level, and then we put the system variable, which is S, and the S underscore means it's a system variable, and then it's just light, and then the units, which are lux. Now if I press enter, and we get the value 215. Have another look. Now if I turn on the light and we take another reading, you can see it's gone up to 299. So this method just lets you print the lux value directly onto the command line. The system variable we looked at before, which was the S underscore light system variable, gives you the raw reading from the light sensor, and that goes from 0 to 64,000. And there's nothing wrong with that, but sometimes you want to be able to control an RC servo, or you want to control a pulse width modulation brightness of a light or something like that. So you want a smaller range. So what the S underscore light 100 system variable does is it scales the value from the raw sensor between 0 and 100. So 0 is 0, and 64,000 is scaled down to be 100. Now, a way that you can view this is, again, just by printing it. So what we're doing here is we're printing the normal system variable value for light, and then we're printing the scaled version. And so, for example, here we have a normal value of 36,904, and that scales down to 57. So this is really useful for situations whereby you want to be able to easily display the amount of light coming in, and you need it to be in a manageable range. I'm here on the start page, and so what we'll do is we'll type in a command to get a reading from the normal reading and the scaled 100 reading. So I'm going to go light. We'll get the normal one first, so that's just S underscore light, and then the scaled reading, which will be S underscore LIGHT 100. Press enter. And so you can see that the light value that I'm getting right now is about 261, and the scaled is 0 because it's a very low light level. So if I get a bright torch and I shine it on the light sensor and I run the command again, see that? So we're up to 9,000 lux in the normal side, and the scaled version is 14. Let's see if I can make that a bit brighter. Yeah, so you can see here now we're at 25,866 lux, and the scaled value is 40. So if I was wanting to control a dial on a servo or the brightness of another light, using the scaled value would be a lot easier than using the normal value, which goes between 0 and 64,000. So the light 100 system variable is really useful for controlling other things. So lastly, we can get the current readings from the light sensor from the live page. And that's really easy. You just go to the dashboard, click on live on the left, and you'll see the values on the right. So I'm back here on the dashboard, and this is the link here to the live page. So if I click on it, what you'll see is these values will pop up. And remember from the previous slide about the GT command, the light readings are actually on channel 34. So if I just put my hand over the sensor, you can see them changing. Now if I click on this row, you can also see a graph of the readings as they change. And these are updated in real time on the live page. So to summarize, light is made up of photons, and the only reason we see things is because the photons travel through space, hit an object, and then get bounced back into our eyes. The light sensor on the JackBord Basic has a detector that picks up the light level and converts it into a value that the JackBord Basic can then use. And that goes back to the detector processing output arrangement that we saw before. The light value range in the light sensor for the JackBord is between 0 and 64,000 lux. And you can use the GT command to get the readings from the sensor, but you can also use the S-Light and S-Light 100 system variables as well. In the next video, we're going to learn about the temperature sensor. To get straight to the next video, simply visit jb.works and search the TMT code shown on the screen. For more information and to get help, visit jb.works.